Hi everyone, welcome back. In this video, we will see various kind of technical terminologies which we are going to use in CPU scheduling algorithms. These are also called as process times, guys. Okay, let's see the first one, arrival time. Arrival time of a process means the time at which process is ready to execute. Which we can call it as arrival time. I mean, once a process enters from new state to ready state, this time at which the process enters into the ready state, which we call it as arrival time. Next one, completion time. The time at which process completed execution. That execution can be again in IO operation or its CPU operation. At any cost, all the entire task it is done, it is called as completion time. Means in after ready state, it will move to the running state. From running state, it will enter into the completion state, right? The time at which it is going to exit the running state, we can call it as completion time. Here you may get doubt, right? It might be exited because of IO completion, but you should not take care about this IO completion. After completion of all the IO operations and all the things, the last time at which the CPU is exiting the process, this particular thing we call it as completion time. Next terminology, burst time. The time for which process need to execute in the CPU. So if it enters into the CPU, the time for which amount of time it has to execute in the CPU, we can define it with respect to burst time. Next one, response time. Response time means generally when a process is in ready state, it will enter into the running state and exit from the running state, waiting state, then again ready state. Like that, it might be happen for some kind of looping. Right? Means there might be a chance to execute a process for n number of times in the running state. But here response time means the time at which for the first time it is responding to the user. Which we can call it as response time. Okay, means when a multiple requests are happening from the user, for the first response you got at what time will be defined by response time. Turnaround time is the next terminology, which means the difference between completion time minus arrival time. We can shortly write in that as completion time and arrival time as 80. Difference between completion time minus arrival time we call it as turnaround time, which means that we can say in other words the total time taken to complete a process once it is in the ready state. Am I right? Yes. Next one, waiting time. Waiting time means the time for which the process is in waiting state. The amount of time for which the process is in waiting state, which we can call it as waiting time. Waiting state are also called as ideal period, right? Then how we are going to calculate the waiting time? In general, try to observe. Waiting time, I can write WT equal to turnaround time minus burst time. Is it the correct one? What is the general meaning of turnaround time? Turnaround time means how much time it has taken for to complete this task. That is what turnaround time. Burst time means what? Out of the total time taken to complete a task, the amount of time for which CPU utilization might happen. CPU utilization might happen. Then if you remove that burst time, that will get as waiting time. Hope you understood. I mean, for example, if I say simple example, my class is going to start at 11 a.m. and it is going to complete at 1 p.m. 1 p.m. At the time at which I came to the class at 11 a.m. and will be ended with the class at 1 p.m. So here turnaround time will be 2 hours. 2 hours. Out of these 2 hours, how many hours do I have taken the class? If we consider, for example, I may be idle for first 5 minutes. It is because to read all the previous concepts, and I will take after 1 hour I will give one break, and then I will start the class after 5 minutes of break, and at the end of 5 minutes I will stop my class again to make the attendance. Now observe here, I have taken the total time for 2 hours. That is what turnaround time. Out of these 2 hours, how much time I have utilized the class? 1 hour for the first class, and I have taken the 5 minutes gap, and again last 45 minutes I have taken the class, which means first 5 minutes I left, middle 5 minutes I left, and here 5 minutes I left, right? So which means 1 hour 45 minutes I have utilized the class, right? This is what CPU utilization. So if I utilize 1 hour 45 minutes and total hours I have taken is 2 hours, what is the idle period what I did so far? These 3 places. That is what we call it as waiting time. So with respect to this one, students are in waiting state for 15 minutes. That is the general meaning of waiting time. Guys, just note down the points. If you are unable to understand, you can clearly understand once we go through the various kind of examples. Next one, mean response time. Mean response time means average of all response times, right? So earlier the fourth technical terminology we discussed, for the first time how at what time you have got the response, that is what one response. Like that it might have a various kind of loops, means CPU allocated and comes out, again allocated and comes out, like that. All kind of response times what it got, if you take the average, that will comes under mean response time. Similarly, mean turnaround time means for a particular process, turnaround time will be considered as one thing. And if you want to calculate the average of all the process turnaround times, that will comes under mean turnaround time. So we can say that average of the turnaround time of all processes, we call it as mean turnaround time. We can say that as 1 by n into, if I say n process, turnaround time of one process plus turnaround time 2 of other process and so on, turnaround time of n process. Okay, next one, scheduling length. Scheduling length means the total amount of time taken to complete all the n process. The total time taken to complete all the n processes. N process either in preemptive mode or in non-preemptive mode. Guys, you might get the doubt here. Then what is the difference between turnaround time and the scheduling length? Here, if you write the formula, you can understand. Scheduling length I can be written as L, which I can say that L equal to maximum time taken to complete a particular process, we can say it as Ci, minus minimum of arrival times of all processes. Arrival times of all process, I can call it as scheduling length. Means the point here is this particular 8 terminology and 9 terminology are related to all processes, are related to n number of processes, are discussing with respect to n number, whereas coming to the remaining terminologies are discussing with only one particular process. Scheduling means if I have n process, out of those n process, for what process it has taken the maximum completion time, and minus minimum of arrival times of all process. That is what we call it as scheduling. Guys, once I take the problems, you can understand it clearly. Next one, throughput. Throughput means generally number of processes completed per unit of time. Right? So if I take here for a period of L, time taken to complete n processes. L means what? Scheduling length. For a time period of L, n process completed. But according to throughput definition, what you have to do? For 1 unit of time, how many processes are going to be completed? Let me take it as x, then you can perform cross multiplication. X into L equal to n into 1 process. Then what will be the value of x? X equal to n by n. This is what the definition of throughput. Throughput means number of processes completed per unit of time. If I am having n process and this n process taken how much time? L time. We can call it as throughput. Okay. Next one, context switching overhead or context switching time means the amount of time taken to switch between one process to another process is called as context switch time or context overhead, which we can generally represent is like this. And next terminology is time quantum. Time quantum means, which we can represent something like in the form of row symbol, means basically we'll use it in the round robin algorithm. The amount of time for which we have allocated a process to execute in the CPU. Process allocated to execute in the CPU. For example, if I say for process P1, 2 nanoseconds time quantum, which means process P1 has to execute for 2 nanoseconds in the CPU and has to come out. That is what the time quantum means. Next one, Gantt chart. Gantt chart means generally used to represent how your processes are executing in the CPU. How your processes are executing in the CPU represented on the x-axis using rectangular shapes, which we can call it as Gantt chart. Guys, so don't worry about it's again the meaning clearly. So if we look into this particular example, you can understand, right? So let me say process P1 is executing for 10 nanoseconds, process P2 is executing for 12 nanoseconds, process P3 executing for 4 nanoseconds, which means how we are going to represent means in the form of Gantt chart. Generally, I am assuming that this is a CPU where initially start with 0 nanoseconds and assume that I am trying to represent this. So P1 is executing for how much time? It has started at 0 and it is going to take how many nanoseconds? 10 nanoseconds. Means P1 completed by what time? 10 nanoseconds. Then assume that given chance to P2 execute for how many nanoseconds? 12 nanoseconds. So it will be completed by what time? 22 nanoseconds. Then give chance to P3 will execute for how many nanoseconds? 4 nanoseconds. So it will be completed by 26. This is what the general meaning of Gantt chart means. By simply looking at this particular Gantt chart, you can able to simply define at what time process P2 starts execution. Can you tell? At 10 nanoseconds. Like that, you can able to answer various kind of questions with the help of this Gantt chart diagram. Okay, fine. So before going for various kind of algorithms in the coming videos, let me try to draw one generalized Gantt chart so that you can understood in a more clear manner. Assume that this is a Gantt chart and it is a Gantt chart for the particular CPU and for a particular process 1. I am assuming, right? So initially start with 0. If any particular process is came at the 0, I can represent as arrival time, right? So once they are arrived, there might be a chance to not to enter directly into CPU. Then it will be placed in the ready queue. I can call it as waiting time. Once the waiting time done, it will enter into the running state. I can say it is entering into the CPU, and this will be the burst time. Guys, I am trying to define it for one particular process Gantt chart. Right? So Gantt chart. Particular process arrived at 0 time and it is waiting to make it for running, right? So as it is waiting, so it will become under waiting time and it will be in the ready queue. Once it got a chance, it will enter to the CPU. That is what we call it as a burst time. And there might be a chance to get IO operation. Yes. Then when it got a chance to IO operation, I can call this as input output burst time. Means it is going to come out of the CPU. Again, after completion of IO, it will enter into the ready queue for further CPU utilization, which I can call it as waiting time, right? If you are able to observe this one, I can call it waiting time 1, burst time 1, input output burst time 1, and waiting time 2. Second time it trying to enter into the CPU 2. Again, after completion of certain time, CPU utilized. This one I can call it as burst time 2. And again, it will be preempted. That's the reason I am calling it as waiting time 3 and it will enter into the ready queue. Then might be used to CPU. Then I will be say that it is burst time 3. Like that, it will be allocated the entire CPU. This is what starting time, I mean service time, and here CPU, right, service time, and this will be service, right, means the time at which it starts using the CPU. I can generally represent this one. Even if you are not able to understand this particular thing, you can able to understand with clear examples. Okay, hope you understood this particular video, guys. In the coming videos, we'll try to look into one by one of various kind of CPU algorithms. Thank you.